Our first presentation is exploring new hydrogeologic data to enhance groundwater management plans with Paul Woodward, Senior Water Resources Engineer at HDR Engineering. So take it away, Paul.
All right, check. Yeah, thanks for having me here. I'll jump right in there. Probably a little bit more information about this from maybe a couple of those speakers too, but really in the eastern part of Nebraska, there was a lot of kind of unknown in the geologic data. You know, we had all the test holes, things of the past. It was really how to tie that together. And so we did a bunch of airborne electromagnetic surveys. I won't dive too much into all the background of that, but you can imagine this helicopter flying over the land, picking up all this data, and it's really getting the resistivity data of the materials beneath the ground, sometimes to 1,000 feet deep. And we really understand what's down there by using the different test holes. So a lot of this data has been collected and is available now, and we're really finding new opportunities and new ways to use it so that we can basically get a better understanding of what types of things are affecting the quantity of water in aquifers, what things are affecting the quality, and how can you visualize that or better understand it, because it's something happening in 3 dimensions, right? But of course, when we get into planning and all these other activities, we want to be able to explain that to people in more of a map, more of 2D. So that's kind of the complicated issue, is how to take what this is showing here. It's kind of hard to see, but anything yellow, red, or orange is basically a better sands and gravels, a better aquifer material. Blues and light blues are more silts and clays. And then the big black line is bedrock. So beneath that might be sandstones, shales, things like that. So a lot of this was done collectively by what we termed the Eastern Nebraska Water Resources Assessment, or NRA. So you can learn more about them just NRA.org. But I talked a little bit about what the survey is. And really now the data is being taken and put into holistic 3D models of what's going on beneath the surface and into groundwater models. So by taking this data and putting it into so many realms, we really have a lot of opportunities now to make better understanding and to look at that in different ways, like different layers, things like that, and kind of pull that information out. So what I really want to get to today was how we're using some of that to make maps to help us better understand the availability, the quantity of water, and how that's recharged, how that cycle kind of works. So that when we go in, every NRD in Nebraska, you probably heard about NRDs already today, but is required under the state's requirements to have a groundwater management plan. And that plan has to address how they understand the quantity of water and what activities they're possibly taking to manage that. So let me just jump into a couple of these maps here. This works. So like some background information that we would typically already have had is like the bedrock map from UNL. Up here. Thinking. All right. Hoping this would work a little bit better. So that was kind of the background. The bedrock map is kind of where that black line was at. Now, one of the things we might want to do is find out where really the saturated sands and gravels are. Just that map. A little better. see that. All right, I did that. Sorry, everybody. Okay, so from that actual data, we could map out both like what is the saturated thickness of all the materials above bedrock? And then this example is in the lower Platte South NRD that you're looking at here. So this is the Missouri River. This is the Platte. The areas in purple are where we found out the groundwater level is actually below bedrock surface. So it's actually in those bedrock materials. But then looking at the other data, we could get a better understanding of where they actually have sand and gravel materials that are part of an aquifer. And this really makes sense if you look at, so this is good information. It helps kind of back up. The NRD previously, this was already their groundwater reservoirs that they had looked at. So they had mapped out quite a few of these other areas. Maybe there's some other reservoirs or other areas to take into account now. So as we update the groundwater management plan, that'll be an important part of groundwater quantity to look at. Jump back here. So we really are able to use this in more detailed ways to kind of understand the saturated thickness of the materials, even infiltration rates, recharge rates. So all these, what I kind of term in our older groundwater management plans, were just paper maps, are kind of coming alive. And we're able to use them in ways to make comparisons and do different things. So one example I had somebody tell me is you could take all this and kind of make a combined data layer of where are you going to get the most recharge, or where do you have the most vulnerable groundwater to water quality issues? You know, now not just based on a couple issues, but based on quite a few different layers of data. We could do the same thing for water quality. Again, overlaying areas where we have groundwater management areas that the district already has in place, or that they might consider wellhead protection areas. What current and ongoing nitrate monitoring do they have going on? So you can look at all those results, both most recent and historic. Looking at where the aquifers are that might be affected. What is the capacity of groundwater flow? That's all brought in. We were really using that resistivity data in groundwater models to tell us, okay, what is the hydraulic connectivity of this aquifer? How's it going to work? So that's kind of come alive, as I mentioned too. Where is that groundwater flow going? Maybe that's the one I'll just jump back to here. So we were able, also to make a pretty detailed groundwater flow map from some of the data that was in turn off the colors, but some of the data that was in the groundwater model. So that's really been effective too at identifying where things in that aquifer are going, because usually we think of it on a more regional basis, like generally the water is moving to the Platte or the Missouri. In this case, you can really see the difference in smaller watersheds as well. Kind of a lot to cover here, but really what I really wanted to get to show everybody is that there's lots of opportunities to take this now enhanced data set that's more has higher resolution, more information in 3D, and to use that in new ways, kind of open up our eyes a little bit so we can see things a little bit differently than we did before. Again, so we're exploring this with people as we're doing these groundwater management plans, so they're providing their insights to, well, hey, I live here and I know the nitrates are bad in this area. And then how can we, better inform people because we have this information, we're not just making one paper map to hand in and say, this is what we know so far. We're able to take it and kind of combine it in different ways. That's all I got.
Thank you, Paul. I think that's like more data than we could have ever imagined for on the flow of groundwater. So I'm gonna open it up for a few questions. If you have them now, hopefully we'll also have some opportunity at the end too. I know that was a quick presentation. So does anyone have questions they want to pose to Paul right now? Yeah.
It's still, okay, maybe. So you showed the picture of how you're actually collecting the information, the helicopter with the sensors hanging down below. How long does it take to collect that information for, say, that one district you were looking at?
So we were probably looking at, I think 3 different years of collection that they did, but, they might have only flown for 3 to 4 weeks at a time, collecting all those miles. If you look at on NRA's site, there's 10,000 miles or more of actually, some places are, as dense as 3 to 4 lines of a square mile. Some are 3 square miles apart or 3 miles apart. But so kind of depending on how thick the resolution was for that. But yeah, it's pretty quick. The helicopter's flying it, I think roughly 100 feet above the ground and maybe for a helicopter, 80 to 100 miles an hour. So they're moving right along and every day they're checking. So we actually are working with in these other projects, working with the company that actually collected and assembled that data. So that we're using, their interpretation the best we can in these data.
Any other
Oh, yeah, I can do.
Yeah, so I saw there was still data that was provided in more urban zones, kind of around Lincoln. I'm assuming a helicopter is not flying that sort of flight path, but how kind of reliable is that data in more of those urban zones?
Right. You're exactly right. No, the helicopter did not fly over any urban zones. So there's a gap of data there. They used anything that was available from other, holes that were drilled, the wells that were drilled to try to fill in some of the gaps. But there is still some level of interpretation in those 3D geologic models and what goes into the groundwater model. So, yeah, it's still not perfect in quite a few of those areas.